Hi, welcome back to my channel. Today's presentation is about statistical analysis with a focus on comparison to hypothetical value, or simply in other words, the null hypothesis testing. The presentation is a part of a playlist on observational research. I invite you to watch previous videos. And we are here part of the quantitative research family of observational research. The objective of today's presentation is to learn to perform a comparison of your group of subjects or your sample to a hypothetical value of the population sample, which is simply called the null hypothesis, and to learn about variance as a basis for inferential statistic to continue with your statistical tests later on. Now, I need to remind you that we already described the different tests for descriptive statistics. Here we are part of the inferential statistical test and one of the earliest ones. An inferential analysis is used to measure the reliability of conclusions about a sample, about a population. Now, if you remember this graph that I showed you in previous videos, it is here classifying the different types of statistical tests that are used in inferential statistics. And here we are at the beginning and one of the first videos that is focusing on the comparison of one group to a hypothetical value, which is called the chi-square test, the t-test, and the Wilcoxon test. We will approach them in this presentation. The content of today's presentation is elaborating on the importance of variance, the assumption test or the null hypothesis test, how to calculate the confidence interval or the significance level, the chi-square test, the t-test, the Wilcoxon test, and finally some takeaway messages. But let's start with the importance of variance and why we need to detect the variance and prove it. Well, first of all, when we conduct statistics, we need to define what is the objective of statistical analysis. And as you can see, there's only 6 objectives to conduct statistics, either to describe and characterize a sample, or to detect the variance, or to compare and test a hypothesis of your research, establish an association or a correlation, 5, predict, or 6, prove causality. In today's presentation, I'm going to focus with you about objective 2 and 3, where I'm going to help you to detect variance and compare your sample with a hypothesis or the null hypothesis. Now, it's very important to analyze variance because statistics always starts with having some variation in the data. If I do not have variation, I cannot continue with my correlation and my regression and with my causality studies. So therefore, variance is very important in comparing my sample or my means or the values of my sample that I collected either with other groups or with the main population that I extracted the data from. So if the variance is 0, the system is deterministic and hence there is no need for statistics and my whole question formulation is not anymore valid. So actually we assume this not as the cause. Assuming this is not the cause of your research, by the central limit theorem, the mean of independent identically distributed random variables converge to a normal distribution, which in turn is unique to mean and variance, giving prominence to this variance. Now, the most important test that all of us must conduct under the inferential statistical analysis, and one of the first, is the assumption test. The assumption test is based on a normality, normal distribution basis, so the most common statistical assumption test that is used for normally distributed data. A normal distribution means that your data follows a bell-curved shape and data tends to cluster around the mean. And to check for the normality, we run a statistical test with a null and an alternative hypothesis. So the assumption test starts with redefining a research question in order to make sure if there will be a difference or a variance or an influence of the parameters or the variable you are going to investigate. And let me go further in detail with this exercise and start to explain the null hypothesis. Well, what is the null hypothesis? It is simply probing that my sample mean is a good mean estimate of the unknown real population mean, assuming that there is an unknown population mean. So simply I start my work with collecting data about my sample. I have my observations, I have my measurements. I can define my mean of my sample because I collected the data itself, but I don't know what is the mean of the real population. So what I'm going to do, I will hypothesize or hypothetically try to use my mean of my sample and compare it with a hypothetical artificial mean that I will propose for the population and start to compare them. This is simply how it works. So the first step of the null hypothesis significance testing is to convert your research question. You have to start with your research question into a null and an alternative hypothesis. Thus, the research question must be concisely articulated before starting the process, because you will have a research question resulting in a question there is no difference, there is no influence of the parameter I want to investigate, and another option that will say I found a difference for the parameter I investigate. So the null hypothesis will be a statement of no difference, while the alternative hypothesis will be having an answer of there is a difference. Now let's go more into concrete examples. I want to investigate, or I'm trying to correlate the uptake or the intake of aspirin of reducing the risk of heart attacks. This is my research question. But I need to formulate it following the null hypothesis. So what I'm going to do, I'm going to say that a heart attack is not affected by the daily dose of aspirin, and I consider this question as the null hypothesis. And then I will have an alternative question that says that the intake of aspirin reduces the heart attack. This is the alternative hypothesis question. Now I succeeded to formulate two questions, one in the form of a null hypothesis, one of the alternative hypothesis. Next step, what should I do? I start to collect the data about this population or this sample or those subjects that will, through their answers, through the observations, through the measurements, I will start to test the two hypotheses. So what should I do? Actually, I want to know if my sample mean is a good mean estimate of the unknown real population mean. And therefore, for each test, I must provide evidence against the null hypothesis. How can I do that? Actually, I will hypothesize artificially a real true mean for the real population mean and compare it with the value of my sample mean that I observed. If the result difference is null, then I reject the hypothesis. If the result is positive, then my hypothesis is valid. I have an alternative hypothesis. I can now move from the variance testing to a regression or a correlation testing and maybe a causational testing. But if the result is negative, I have no other way. Sometimes some people who find that a hypothesis is null and they are still feeling, they have a gut feeling that still there is a correlation between, let's say, the aspirin dose and the reduction of heart attack risk, then you need to go for power statistical testing, which is a more sophisticated type of analysis. But in this case, if it's null, you have to stop. So in other words, the H0 or the null hypothesis is assumed to be true until proven otherwise. So meaning that if I have no difference between my sample mean and between the hypothetical real population mean, then I cannot claim that my hypothesis is positive. However, if my alternative hypothesis HA is the hypothesis that I'm seeking getting positive, this means that my proposal is working. So if you want to bolster your hypothesis and you still have a negative results, the only way is to do power statistical testing. I don't promise it will give you a positive result, but that's the only way to get out of it, or to simply to recognize that there is no difference and actually there is no influence of the aspirin uptake on the reduction of the heart attack risk. This is simply how it should be done when you have a research question, when you have a sample, and how you are trying to investigate the null hypothesis. So actually, the hypothesis predicts variance. The positive hypothesis or the alternative hypothesis predicts variance, association, or correlation that must be tested after the data collection, and the chosen variables must be tested for correlation that might lead to regression relation. If your hypothesis is null, you cannot conduct this series of tests and you cannot follow this logic. Therefore, we need every time to know very good in our study what are our variables, what are our subvariables, what are the indicators. we conduct the analysis of variance and the hypothesis, the variance hypothesis testing through the null hypothesis test. And only if we have an alternative hypothesis, we can start to investigate and use other type of tests that allow us to prove the association or the correlation, the regression, and finally maybe examine the causality, if it is there. Now, again, I need to remind you that we are operating under the normality, normal distribution conditions, so always you have to test for normality. We run the normality test for the dependent variable, which consists of continuous data, ratio or in the form of ratio or interval. Categorical data is not normal in this case, and the common test that we can use for our null hypothesis that you can find in different software like R, Python, the statistical software is the Shapiro-Wilk test, which is used to reject or to accept the null hypothesis, and data is normally or not normally distributed in this case. Below 0.05, we can reject the null hypothesis. So actually there is a standard protocol, standard procedure for the null hypothesis test, and here how you can use it. Now let's move to another important test that we need to take into account when we try to compare our sample to the population. We do actually the significance level. Allow me first to talk about the probability as a basic foundation for the significance level of our tests. Actually, the probability is represented through the p-value, and the probability value can be between 0 and 1. And the p-value is the probability that sampling variation would produce an estimate further away from the hypothesized value if the null hypothesis were true. So it's a measure for the strength of evidence against the null hypothesis. And as you can see, here we are looking at the statistical significance test, where we have that the claim that a set of observed data are not the result of chance, but can instead be attributed to a specific cause. So we use also that test of significance, of level of significance, to, if we have an alternative hypothesis, we go further with that to investigate the significance of the result or level of significance of our results. Now let's go to the further important test that we need to conduct in our comparison analysis. We need to use the chi-square test. And the chi-square test is a hypothesis test that is used to determine whether there is a relationship between two categorical variables. For example, I have a gender, this could be a categorical variable, and I have a preferred newspaper reading, or I have a frequency of the use of television, or I have the education level. So I start to correlate the gender to the newspaper, the preferred newspaper to the television, gender to frequency of television to highest education. And here I am starting to compare and test any correlation between a parameter and another one. So the chi-square is so useful if you want to compare two different variables, and you have a hypothesis that claims that there is a correlation between one and another. So it's another or advanced type of test similar to the assumption test. Here, when we conduct the chi-square test, first of all, we must make sure that the dependent variable should be continuous. The independent variables consist of two categorical groups. The independence, we have independence of our observations, and the dependent variable should be approximately normally distributed, and that we have a homogeneity of variance. Also, another important condition for the success of our chi-square test is that the dependent variable should be nominal or categorical, and the independent variable must consist of nominal groups, and the independence of observation is a must. Another important or information I can share with you is actually the equation that can be used for the chi-square test. Actually, here is the formula, and we are using the formula to test whether the observed frequencies are significantly different from the expected frequency. And here we have observed frequencies in the form of 0 and the expected frequency in the form of e. We simply have the chi-squared, x squared, is the sum of the observed values minus the expected values squared divided by the number of the expected values. And based on that, we can calculate the chi-squared value. And when performing an inferential test in general, you begin from the point of the unknown, meaning that there is no relation between the variables. This should be always the assumption of the beginning, and this is, in this case, we will call it the null hypothesis, like we explained. And then the opposite or the alternative hypothesis will mean that there is a relationship between the variables. And as you can see, we will try to see that if the p is higher than 0.05, then there is no relationship between those two categorical variables, and if the value is less than 0.05, then we can prove that there is a relationship and that we can go for the alternative hypothesis for those two categorical variables. So this is how it is calculated, and this is very important test following the hypothetical assumption test, or the Wilcoxon, Shapiro-Wilks test. Now let's talk about another important test, which is the t-test, which is part of those important tests to compare our samples. Well, the t-test is a statistical parametric test that is used to compare the means of two groups. Here we are comparing a mean of two groups, and it is often used in hypothesis testing to determine whether a process or a treatment actually has an effect on the population of interest, or whether two groups are different from one another. So again, it is another type of test of comparison of means. And as you can see here, first questions that we need to determine, when can we use this test? First of all, we have to ask ourselves, are the two sample sets same or related? If yes, we can directly do a pair-dependent test. If they are not related, then we have to ask ourselves, are the two sample sets having the same size? If yes, we can directly go the equal variance independent test. And if again the answer is no, then we have to say, do the sample sets have the same variance? If yes, we can go back to the equal variance independent test. If no, then we have to do an unequal variance independent t-test. So this is the logic behind it, and here you can see the variation of results of different t-tests, where we can have here a moderate variability, a high variability, a low variability, and every time we are calculating the population mean score and the significance difference. So another test that allows us to characterize and better compare the difference between two different samples. Now I'm moving to the last test that could be used as part of this comparison test for the hypothetical value of your assumption, which is the Wilcoxon test. The Wilcoxon test is a non-parametric test and is therefore subject to considerably fewer assumptions than its parametric counterpart, which is the t-test. For the dependent samples, the Wilcoxon test tests whether the difference between two observations has a mean signed rank of 0, and that the hypothesis of the Wilcoxon test tests whether there is a difference in the central tendency. So this is another important test, can be used either in the hypothetical analysis or into comparison of two variables in two categories. Well, this is the end of today's presentation. Some takeaway messages before leaving you. Well, the chi-square test is a hypothetical test used to determine whether there is a relationship between two categorical variables. The t-test is a parametric statistical test that is used to compare the means of two groups. And the Wilcoxon test measures whether there is a difference in the central tendencies, and it can be used for the null hypothesis for your assumptions. Make sure that take care that it is often used in hypothesis testing to determine whether a process or a treatment has an effect on the population of interest, or whether two groups are different from one another. Through those three tests, we can test our null hypothesis and get familiar better with our sample means and the population means, and check if our research question will have a positive alternative hypothesis answer, or it will have no difference and no variance. Well, this was the end of today's presentation. I invite you to watch the following videos on the different statistical tests. I thank you very much for your attention. Today's presentation was about the statistical analysis and the comparison to a hypothetical value, the null hypothesis. Thank you for your attention.